laws to find the equivalent resistance. Like over here, we have a skeleton of cube where we have only edges, and each edge has a resistance R, and we have to find out what is the equivalent resistance between A and G. So over here what we can do is, if you have to use the Kirchhoff laws, we can connect it by, let's say, a battery of V volt between these two terminals. We know current shall be, positive current shall be entering over here, we call it as I. When the I current enters, so this I current will split over here. It has three ways, three paths, this and this. Now we have to find out, that is, how this current is going to divide between these three paths. If you look out for the shortest path, when the current enters over here and exits over here, one path is, that is, it goes this way, this way, this way, this way, and the shortest path is 1, 2, 3 and exit. If it goes from here, 1, 2, 3 and exit, and if it goes over here, the shortest path is 1, 2, 3 or exit, or 1, 2, 3 or exit. So it means minimum it will have to come across three resistances. All the resistance they are equal to R. So for any path, whether it enters over here, whether it enters over here, whether it enters over here, it will have to come across the three resistances as in the shortest path. It is not the longest path. It is not any path. We have to look out for the shortest path. Then only we can say something about whether the current is going to divide it equally or not. In this case, whether it enters over here, whether it enters over here, whether it enters over here, the shortest path is of three resistances. 1, 2, 3 exit, 1, 2, 3 exit, 1, 2, 3 exit. The shortest path in all these three cases is identical. So it means the current will divide equally amongst these paths. So it means if I is here, so I by 3 will go this way, I by 3 will go this way, and I by 3 will go this way. Once I by 3 reaches over here, once again it has two options, this and this. Once again we look out whether these two paths they are identical or not. Yes, they are identical. 1, 2 exit. For this also 1, 2 exit. The shortest path, whether it goes over here or whether it goes over here, the shortest path to exit is once again same. So this current I by 3, it will once again divide equally between the two. That is, half of this will go over here and half of it will go over here. So half of I by 3 is I by 6. So I by 6 goes over here and I by 6 goes over here. Similarly for this also, once again when I by 3 reaches over here, it has two options for exit. One is it goes this way, the other is it goes this way. If you have to find whether these two paths they are identical or not, we look out for the shortest path. Shortest path is 1, 2 exit, and for this also 1, 2 exit, and both the paths they have the same resistances. So these two paths they are identical. As a result, the current will divide it equally. That is, I by 6 goes this way and I by 6 goes this way. Same way for this, I by 3 reaches over here and it has two options, 1, 2 exit, 1, 2 exit. So it divides equally. That is, I by 6 this way, I by 6 this way. So if you look at the junction H, I by 6 comes this way, I by 6 comes this way. So this way and this way, I by 6 coming. So this way the current will be in this direction. And using Kirchhoff current law, this plus this is equal to this. I by 6 plus I by 6 is I by 3. And similarly for this junction, I by 6 is coming this way, I by 6 is coming this way. So I by 3 is here, I by 6 coming this way, I by 6 coming this way, I by 3 this way. And if you look at junction G, I by 3 coming this way, I by 3 coming this way, I by 3 approaching this way. So this plus this, it makes I only, the I current reaches back the battery. I was coming out from the positive terminal, I is once again getting into the negative terminal. So now what next? Now what we can do is, we can take any path. Let's say we take a path V, we call it a V only, V, A, D, C, G, V. That is, if we take this path, V, A, D, C, G, V. Suppose we take this path and we say this potential difference between A and G. What is the potential drop? It is only V only. The potential drop between A and G is V only. So this drop is among the various resistances. You take any path. It may be a drop against some of the resistances. It may be a gain of potential against some resistances. But the net potential drop against A and G is going to be V only for any path. So this way, when the current is going this way, so this is a drop only. We can take any loop also, and we can use the mesh rule where we have taken the drops as negative. Otherwise, we can say that this total drop is V drop is going to drop across this plus drop across this plus drop across this. So this drop V is going to be drop across this. It is going to be I into R, that is I by 3 into R, plus the drop across this, that is we are using Ohm's law only, that is potential drop across this is going to be I by 6 into R, plus the drop across this, that is plus I by 3 into R. So this comes out to be 5 by 6 IR. We can take any path. Even if we take, let's say, we take A, B, C, G, V. So once again we see that a potential drop across this and this is going to be V only. Across some it is going to drop, across some it is going to be gain. Let's over here, if we take this as, so once again I by 3R plus I by 6R drop, and across this once again I by 3R. We can take any path. If we take a more complicated path, something like this. So over there also we are going to have some losses, and when we go from here to here there is going to be gain, but that will once again compensate it for a loss. So overall it will come out to be same. For any loop it will come out to be 5 by 6R. When we say we have to find the equivalent resistance for this network between A and B, so it means we can remove this whole network, and instead of this we can use a single resistor of R dash, which is equivalent resistance of this. It means from the same battery the same current should be drawn. That is the meaning. Equivalent resistance is that single resistance which draws the same current from the same battery as being drawn by the combination. So it means over here this whole network, if it was drawing a current I from this battery, so this equivalent resistance should also draw the current I from the same battery. If we use Ohm's law over here, so we say V is equal to I into R dash. From the same battery, same current is drawn. So it means whether we say this V or this V, that is one and same thing. So V is equal to 5 by 6 IR, and over here V is equal to I into R dash, where R dash is equivalent resistance. So equating the two, 5 by 6 into IR is equal to I into R dash. So R dash comes out to be 5 by 6R. So this is the equivalent resistance between A and G. So R dash is the equivalent resistance between A and G of this cube, where all the edges they have a resistance equal to R. This way we can use the Kirchhoff laws and method of symmetry to find the equivalent resistance.